So the past few years have truly been really chaotic. Over 70% of our corals have been bleached. Last year, we officially breached the 1.5 degrees Celsius global warming from pre-industrial levels for an entire year. And the results? Floods, unseasonal droughts, and a multitude of natural disasters. And from 2019 to 2022, India, West Asia, and Africa saw one of the largest locust infestation in recorded history that had a devastating effect on food security. This is just the beginning of a new normal that climate change has brought us. Hello everyone, I'm Ishaan Surve, a 16-year-old innovator from the Dhirubhai Ambani International School, India, who wants to harness the power of STEM and technology to find modern solutions to these environmental challenges. I first began my STEM journey in 6th grade while doing an action research project on mangrove conservation in India. I was spellbounded to learn about the impact IoT technology can have on this sphere, and that is when I began by learning Java. After I developed, programmed, and launched my first app on Google Play Store, I knew I was hooked for programming and I wanted to do something in STEM. Over the years, I've explored science and technology further, and I had the honor to represent my school in the first robotics challenge at New York for my robotics team, where I won the Safety All-Star Award and my team won the prestigious Ford Autonomous Award. In addition, I love physics, so I participated in the International Young Physicists Tournament, where I researched on 17 open-ended problem statements and presented them in front of a jury and an opponent. I ranked second in India, and I will be representing my country at Budapest this year. I have also participated in multiple hackathons, and I enjoy coming up with solutions to problem statements. For example, at the IB Leagues organized by JPIS, I won the Most Innovative Award for a solution that used ionized beams to deflect asteroids. And at the Chittagong Grammar School, my game on censorship won the first place. Now, how can we develop solutions that will tackle the environmental problems for today? We need a new developmental paradigm, something completely different. And that is when I discovered biomimicry. Biomimicry is an exciting new approach to STEM, where innovators study nature, learn from it, and mimic its mechanisms to innovate solutions. Nature has attained greater perfection than we have. After all, it has had billions of years of natural selection and evolution. For example, this image here, it is a comparison of a bee's sting and a knife at a microscopic level. As you can see, the bee sting is much sharper and applies much more pressure than the knife. And we have been developing knives for tens of thousands of years. Similarly, we have so much more to learn and gain in the spheres of carbon storage, sustainable architecture, and even search algorithms from natural ecosystem components. So the innovative project that I have been working on and I'm excited to showcase is Project Maina. A major problem towards food security, which is impeding the UN SDG goal of zero hunger, a single moderate locust swarm consumes enough food grains for 35,000 people in a single day. And these can last for entire years. Between 2003 to 2005, we tried to control a locust swarm at a cost of $600 million and 25 million toxic pesticides. These pesticides entered our ecosystems and our food, and through bioaccumulation and biomagnification, posed a health hazard and led to much soil pollution. Because once a locust swarm is formed, it is incredibly difficult to control because it is composed of a multitude of organisms that have now become immune to different toxics. these locust swarms also threaten the livelihood of about 42 million people. So let us talk a bit further about these locusts themselves. So locusts are insects with an interesting life cycle. They can be either solitary or gregarious. A solitary locust is like a grasshopper and it is harmless. However, due to overpopulation and overcrowding, these solitary locusts release serotonin, and these serotonin inspires a transformation in these locusts into gregarious when they start swarming together. And once a locust swarm is formed, it can fly at a speed of over 130 km per day, migrate over even the Red Sea, and go throughout the entire nation and leave fields barren, affecting farmers and food security. So my solution is developing an artificial intelligence powered system that would identify the very moment a solitary locust is going to transform into a gregarious one. And once it detects that moment and the location, it would initiate the release of serotonin blockers that would prevent the swarm formation. This would be extremely effective because, as the old saying goes, prevention is always better than cure. I have already developed a prototype AI model that can differentiate between gregarious and solitary locust images. I have trained the model with over 5,000 images from both classes, programmed it using Python and Jupyter notebooks, and developed a convolution neural network that has achieved a 72% accuracy on the validation dataset. In the future, I want to improve my model further and bring it to about a 99% accuracy and develop a user-friendly app which farmers can easily use to detect whether a locust swarm is happening near their field or environment, and once that is done, release the serotonin blockers required. Eventually, however, I would like to develop an entire autonomous system that would be able to explore the entire region effectively. I would mimic the system to the swarms of bees and other insects. A bee swarm is really effective in coordinating between millions of its organisms and exploring and finding pollen from miles across. And I believe that drones, when programmed correctly, can function the similar way. So, what impact can my project bring? My project would help prevent future locust outbreaks throughout the world, because when we detect them before they have grown bigger, they're quite much more easier to handle. It would also save the billions of dollars that are wasted in chemical pesticides by farmers to try and control these swarms once they have established. It would protect it would be a good thing for public health since pesticide usage is reduced, and it would protect millions of hectares of agricultural land, both from the locust and the chemical pesticides. And it could save over 20 million people who are at the risk of starvation due to these locust infestations. I would like to thank STEMX for this opportunity to showcase my project. Thank you.
Thank you very much, Ishaan. Thank you. It was a very insightful presentation indeed. So now we'll let the judges decide with the question answer.
Very impressive, Ishaan.
Ishaan can remove your sharing. Yeah.
Okay, yeah.
Ishaan, you said you conducted action research.
Yeah.
Yeah. Since when you are working in action research, Ishaan?
So in 6th grade, I conducted an action research project for the Homi Baba Balvinayak competition. So that is a statewide competition organized throughout Maharashtra. And at that moment, the topic was nature. So I chose mangrove conservation because I was fascinated by mangroves after visiting them at a nearby site. So yeah, I learned a lot throughout that experience, especially how IoT can be used.
And I can see you're interested in nature and studying the nature and solving the problems of nature. This is a wonderful topic to be interested in your age. How many action research you conducted? Is it one or a series of action research, longitudinal one you conducted since grade 6 till now, or different action research in different topics?
So I've been exploring nature on a wide basis. So for example, the Homi Bhabha research project I spoke of on mangrove conservation, that was for about a year, where I interacted with stakeholders from across Mumbai and developed my own solutions. This locus-based prototype, which problem statement I've chosen, for that I have done background research to understand the problems being faced.
What's your plan for higher education? Are you going to study computer science? I can see that you use
Yes,
computer
I would
science
like
language. Yeah,
Yes.
computer science.
Yeah,
Well done,
I would like to
Ishaan.
explore.
Thank you.
Yeah, thank you.
Okay, let me ask you something else, Ishaan. Thank you very much for the nice presentation. It's a very good idea, the one you created. But I'm going to discuss one point with you. You know that God created everything for a reason, right?
Yes.
Yeah, and you spoke about the locust swarm and how they are affecting the crops in your country. So don't you think that killing that big amount of the locust swarm will affect the food chains for other animals?
Yeah, I get your point, but my solution does not advocate for killing locusts at all. In fact, what it calls for is a locust has a different life cycle. So a solitary locust like a grasshopper is completely harmless. But under conditions due to humans, for example, we have undertaken urbanization, industrialization on a large scale. So these locusts have very little habitat. So they are forced to converge on a particular area, and that has led to overpopulation amongst them. And that has stimulated the serotonin release, which turns them into these harmful locust swarms. So my solution is identifying when a locust swarm may be occurring and just placing harmless serotonin blockers, which do not affect the locust in any way, but prevent them from becoming these swarms. So in a way, we are ensuring that neither the locusts nor us humans, which rely on agriculture for food, are harmed, and it's a win-win situation for both.
Okay, thank you very much, and all the best for you, Ishaan.
Thank you.
Oh, nice to meet you, Ishaan. I was particularly interested when you started speaking of how this, involved, how climate change was involved. But I had a, similar question from Dr. Meena, that if you are you're changing something that is naturally exists, you're changing something that is there for a purpose. What kind of predicted side effects do you anticipate? If you change them, do you see any change in reproduction or any change in their social behavior, or perhaps this swarming would take place at a different time? I mean, think nature has a way of correcting things when it's been changed. And I'm wondering if you think to yourself, what would be the result of making this change? What could be the potential result besides food security? I mean, obviously you'll have more food. That's great, but what are the other possibilities? And and not just the food chain, but the food web. How would it be affected?
So releasing the serotonin blockers itself would not affect the locust biology in any other way. They would still be able to reproduce and function normally. What a serotonin blockers effectively does is that it provides some breathing space for both humans to prepare for the locust swarm disaster and an opportunity for the locusts to disperse into other areas and regions. And it wouldn't affect the ecosystems itself, and in fact locust swarms are perfectly natural normally. But right now, because of climate change, urbanization, industrialization and deforestation, they are occurring at a much larger frequency than normal.
Thank you very much, Ishaan.
Thank you.
Thank you. Thank you very much, Ishaan.
Thank you.